Chapter up and running. All right, let's see. So I posted an announcement yesterday. We are not going to do SLP presentations. So everybody just got 25 out of 25 on their presentation. So nice work on that. In winter, we'll combine our presentations with Izad's 252 class, and we'll have a big expo, probably remote, possibly in person, probably remote, and it'll have the engineering, computer science classes all combined, and it'll be one big expo. So we'll do presentations then. But you already did presentations for PA4, and that's good enough for me as far as that aspect of the course. And as I said in the announcement, I want to save time because there's still a lot of good topics we can talk about for this class. So yeah, if you want to use code, if you want to share scripts that will test your code for PA5, I'm totally okay with that. A few people have packetized scripts that will basically run your code and generate output and compare it to the approved output. And so if you want to use those scripts and if those are included in your repository, that is totally okay, as long as your program itself for PA5 is your own. That's the only concern there. So yeah, you're good. Alright, so no SLP presentations next week. Make sure you upload your poster on time. And this week is a short week. So we have class today and tomorrow, and that's it. And then get 5 days off. And then next Monday is the last week of the quarter.
Oh, is that why there's like week 11 in like a lot of my classes? Is because the way that the classes, or the way that the starting and ending date ended up, it kind of ended up being.
So fall usually ends up being an 11-week term. The other quarters are 10 weeks. But because we have a few holidays and then we miss 3 days around Thanksgiving, we end up about a week shy. So fall's always an 11-week quarter. Which makes it interesting to schedule. Alright, well, what I want to talk about today is awk. And we've already, used awk to do some kind of rudimentary string processing to break up an input line into fields. For example, if you have a date like, December 25th, 2021, we could say awk and say field separator slash, and then pipe this into it. And if we said print, $curly, it's easier to type than write, print $1, right? It would break this input string into fields where each field is a thing separated by whatever the separator is. Normally it's a space, but with a dash F it's this thing. And so this is field 1, $1, this is $2, $3. So if we want to know the month of this date, we could do an awk-f, print $1, and it would print out the month, right, that first field. So we've done that already, and that's a really useful application of awk. Because a lot of times you just have, something on a input line and you want to break it into pieces. And you can do this to do all kinds of quick processing in Bash. But awk is a lot more than just, breaking an input line up into fields. It actually has a whole programming environment inside, including associative arrays, conditional statements, looping, an ability to use regular expressions and all kinds of things. So I want to dig into the details of that.
Script?
Yeah, you can write an awk script. In fact, we're gonna play with a bunch of awk scripts.
That's what Callum did to run his program in like 0.02 seconds.
Okay, but hopefully not for the one that's turned in, because awk's not allowed. Well, awk is allowed actually. Yeah, okay, that's cool. All right, let's see. All right, let's go ahead and do an attendance ping. All right, cool. All right, so let's talk about awk. And awk is actually gawk on our system. It's the GNU version of awk, so the manual page will be slightly different. But it's GNU awk. But basically the same thing. For what we're going to do with it, it's not going to make a difference. So how do we use awk? And I'll just keep calling it awk. So the basic setup is usually awk space and then a program space and then a file name. Could be multiple files. And so if we say something like awk space quote curly bracket print $3 comma $1 curly bracket quote space tilde slash bash rc. So the program is this second argument here, this thing that has a print with $3 $1, and then the third argument is just the file name. I'm just going to pick on my bash rc script. So if I do this, I get the first two. I get two fields from each line. I get the third field followed by a space followed by the first field. So it's just picking out pieces of my bash rc. So you know the last line is alias clean equals all of this stuff, which just showed me alias. That was the first field. Number sign clean up attendance chat. So number sign was $1, up was $3. So that awk program said print $3 $1. So it printed the third field followed by the first field. So we've been using awk to, you know, split up fields in this way, right? Doing things like that. But we're actually defining a program and then asking awk to run that program on a given file. And if we have a more complex program, we can use a switch and say awk-lowercase f and put in the name of a program file, so a file containing a set of awk statements, and then list a file that we want to process. And so we'll get into more complex programs. We'll use this format for representing the program. All right, so we already know about the -f separator. So by default, awk splits things by spaces. So if I just want to print $1, it'll just print out the first field. Whereas if I don't have any commas, the whole thing is the first field. And like all programs in Unix, if I don't specify a file name, awk processes standard in. So if I had put a file name here, it would run this program on that file. Without a file name, it's processing standard input. So we can specify a field separator. So let's look at programs in awk and see what we can do. So the general setup for a program is the following. There's a pattern, and then curly brackets and some action you want to take. And awk works line by line, so it reads a line from your input and it runs your program on that line. And then it reads the next line and it runs your program. And it keeps running your program on each line of your input, basically. So it's fundamentally a line by line processing mindset. And typically what we're doing is we're doing something on each line that involves breaking the line into fields, right? Things separated by a separator. But the general behavior of a awk program is we can specify a pattern, and if that pattern matches the current line, then some action is taken. Now if we don't specify a pattern, if we just say curly print $1, that's applied to every single input line. But we can specify that you only want to do some action on certain lines that satisfy some condition. So we can define patterns. And there's a few special patterns. There's a pattern called begin, uppercase, which always matches at the beginning of the file you're processing. So if I say begin and I put in some action, that will always take place in the start of the file processing. And there's another pattern, end, which always takes place at the end of file processing. So those are special patterns. All right, we also have some variables that are available to us throughout our awk program. So $1, $2, etc. These are the first field, the second field, the nth field of our input line. $0 is the entire line. So if you just want to glom everything together, that's the entire line. NF is the number of fields on the current line. So if this line has 3 things, you know, separated by whatever the separator is, NF would be equal to 3 on that line. NR, this is the number of records, number of lines that have been read so far.
I basically did that to do the equivalent of command line arguments for it.
Right, cool. Nice. All right, so let's take a look at some sample programs. So I'm going to pick on a file called foods. So foods is a space-separated file with 4 fields on each line. There's a name of a food, there's a category of it, there's a color, and there's whether it's cheap or expensive. Okay, kind of an arbitrary file. And so F0 is a file that is an awk program, and it's got 3 lines to it. Now my first statement of my program is split up on 2 lines, but it's a pattern followed by curly brackets and an action. My second line is a pattern followed by curly brackets followed by an action. My third line is a pattern followed by curly brackets followed by an action. And so what this program does is at the beginning of processing, it prints out a header, food space color, and then it prints out some underscores, some dashes to look like underscores. And then on every line of input, it checks the following pattern. In this case, the pattern is the length of the first field is less than or equal to 4. So there's an example of using a pattern. And the action, if the length of the first field, the name of the food, is less than or equal to 4, is print the first field, which is the food, followed by the third field, which is the color. Right? Food, color. And so this will apply on every line where this pattern is matched, this condition is true. And then at the end of all the processing, this pattern end is going to match, and it's just going to do one thing, which is just print out goodbye. So that's a file called F0. If I say awk-f F0, and I run this on foods, I get a nice little table. There's my header that came from that original, begin pattern. And then for each line where the length of the food name was less than or equal to 2, so peas, corn, OJ, right, it printed out the first field and the third field. So the name and the color. And at the end of all the processing, it said goodbye to let you know it was done. All right, this is tricky to do in Bash. It's fairly straightforward in C, but it takes a good amount of work, right? You need to make a character buffer, you need to read in a line, you need to do an scanf to break it into fields and make sure you've got at least 3 fields and so on and so forth, and then do a string length and stuff like that. It's doable, but it's a fair amount of work. It's 4 lines in awk. And if I just do this from standard in, right, there's the beginning heading that got printed out before it ingested anything. And if I don't have a third field, it doesn't break anything. $1 is the first field, but there is no $3. That's okay. You can still check the length of $1. It's less than or equal to 4. So it just printed that out. If I have an empty line, right, that's got a length less than or equal to 4. If the first field has a length bigger than 4, it won't echo it out, and so on. And if I'm reading from standard in, as usual, I hit Control D to signify end of file, and then this end pattern matches, and it goes ahead and performs whatever action is here. Just saying goodbye. Alright, here's another file, another program, F1. So my begin looks like the same kind of thing. It's going to print out a header, but I'm also going to print out an extra field in the beginning, which I'm just calling number. And my print statement on every record is to print NR, which is the number of records I've seen so far, a space, and then $0, which will be the entire input line. So this is going to basically echo my input, but with a header in the beginning and a field in the beginning that will number each line of output. And then at the end, I'll say total number of records, and I'll print out the final value for NR. So if I do this, I've got a numbered list now. So that's the original foods file, but I put a consecutive number in the beginning, and then at the very end, I said total number of records is 17. So suppose I just want to print out every line where the first field has 5 or fewer characters. It's a one-line awk program, right? I could do this on the command line. I could just put this, I could just say awk, all of this stuff, foods, and it prints out the entire line, $0, wherever that first field has 5 or fewer characters. So it skipped spaghetti and coffee, but it gave me mango, corn, and peas. And this is one of these things where if you use awk for a little bit and you get familiar with these capabilities, sooner or later you'll find yourself in a situation where you really want to do something just like this, right? You want to like subset a file of data with the lines that satisfy some length criteria or some other pattern, and it's a pretty quick slam dunk. I can make an awk statement. I'm not going to specify a pattern. I'm just going to say print nr, comma, $0. Commas will separate things with a little bit of space. And so this will print out the number of the record followed by the entire line, and it will do it on the foods file. So that's a really quick way to add line numbers to a file. If I did this on my bash RC, now I've got a copy of my bash RC, but with numbered lines. Maybe that's something I want to do, maybe not. If I don't put a comma, everything will get set out side by side, but I also have the option of, you know, putting a space in like that. So it's a pretty flexible, pretty forgiving language. All right, we can also do kind of an alteration. So for a pattern, we can have condition 1, comma, condition 2. And this is a kind of peculiar pattern. What happens here is awk starts processing the input file, and it starts processing until it finds a record where condition 1 is true. And up to that point, this pattern is considered a fail. It does not match the pattern. As soon as it finds an input line where condition 1 is true, it says, okay, this pattern matches. And the next line it reads, the pattern will match. And the next line it reads, it will consider a match until condition 2 is satisfied. When condition 2 is satisfied, it will say, okay, this pattern matches, but the next input line will not match. And it will go back to not matching until condition 1 is true again. So we can start to sandwich our input like this. Let's say this is the sequential lines of input, and we have a pattern C1, comma, C2. And suppose, you know, on this line condition 1 is satisfied, on this line condition 2 is satisfied, down here is condition 1, down here is condition 2. So all of these lines would be considered a match for that pattern, and all of these lines would be considered a match for that pattern. And the other lines would not.
What happens if C2 comes twice?
Like if C2 comes here, it doesn't matter. None of these will match until C1 is satisfied.
Okay.
So we can do all kinds of strange things with this, but the most common use for this probably is just to pull out records between a certain set of lines. So for example, we could say number of record equals 3, comma, number of record equals 5. And this condition will be satisfied when you get to the third record. And this condition will be satisfied when you get to record 5. And so this pattern would match these records right here. And it's an easy way to say, hey, I want to look at lines 3 through 5 of a file. And so we could do something like this. So number record equals 10, number record equals 20. And let's just print out the line number followed by the line itself, and we'll just pick on our bash RC file. Well, let me pick on something that's still on our screen here. So let's print out lines 365 through 369. Oops. Alright, so there's 365 through 369. Same thing that we had up here. So that's a pretty quick and easy way to subset an input file if you know record numbers that you want. Or, you know, if you wanted to pull out all of the comments from a program, you could search for, you know, this being present on your line as condition 1, and this being present as condition 2. And then everything between these two marks, including the lines containing those marks, would match your pattern. And so you could make yourself a output file that contains all of the comments from a piece of C code, assuming you wrote your comments, you know, like that. And you might have to get into escapes with the slashes and so on, but that would be the basic setup. All right, you can also use regular expressions inside awk. And so we can use something you see in Perl programs sometimes. So we can say field, can't use a tilde. We can say, you know, expression 1 and tilde and a slash and a regular expression. And this basically says whatever expression 1 is, could be a field or a collection of fields or something like that. Take that expression and compare it to some regular expression and see if that regular expression matches whatever this expression is. And if it does, then this pattern is considered a match. And if it doesn't, then it's not a match. So here's a an awk program. And there's a single action to be taken here, right? There's no pattern. So this action between the curly brackets will apply to every line of input. And the action is an if statement. It says if the fourth field, which was the price of the item, matches the regular expression cheap, then I'm going to change that fourth field to say under $2. Otherwise, I'm going to change the fourth field to say over $2. And then I'm going to print out the entire input line. But when I print it out, that fourth field will have been changed to one of these based on whether or not the fourth field matched this regular expression. So here's the original foods. If I run it through awk and I say F5 is the program I want to apply, then, you know, cheap and expensive got changed to under $2, over $2. And we can make this regular expression more interesting. All right, questions so far? All right, so one of the nice things in awk is that it understands associative arrays. So we know what associative arrays are, right? They're an array where the index doesn't have to just be an integer. It can be a string. And so if we say data bracket, you know, hello, that's a bona fide variable. We can give it a value. We can read its value. We can also do something to say, hey, show me all the indices that have something assigned to them in this associative array, so we can read the data back out. Before I get to associative arrays, let's just get to variables. Let me do that first. So here's our same regular expression pattern match statement. So we have a special begin statement. So in the beginning of this program, I'm going to set two variables, cheap and expensive, to be 0. And I'm going to have a pattern which says the fourth field matches cheap. And if that pattern matches, the action is going to be increment my variable called cheap. And if the fourth field matches expensive, then my action is going to be increment the variable expensive. So these are going to count how many lines have a fourth field that matches this or this. And at the end of all of this, after I finish processing input, I'm going to have the end pattern and have two actions that take place. Here I'm going to print out cheap foods and %d with cheap, and expensive foods %d with expensive. And this formatting works just like printf in C, so we can stylize it however we like. So this should give me a tally of how many records have this or this in the fourth field. So you run that, and we got 11 cheap foods, 6 expensive foods. I could also grep for expensive in foods and pipe it into word count and see I've got 6. And I could grep for cheap in foods and pipe it into word count and get 11. But this is actually checking only in that fourth field. So if I had a food called, cheap Oreos, they wouldn't count that as a cheap in there. All right, so we can extend that to associative arrays like this. So I'm making an associative array called foods. How does it know that? Well, all the arrays in awk are associative. And since I'm using foods bracket something, and it hasn't seen this variable foods before, it says, okay, foods is going to be an array. Don't have to specify size or anything like that or type. It's an array. All right, $2 is the type of food that I have, so a drink, a cookie, a fruit, etc. And so my one action that I perform on every line of input is foods bracket $2 plus plus. So if $2 is fruit, this first statement says foods bracket fruit plus plus. Well, if this is the first line of input, foods bracket fruit doesn't exist. It hasn't been given a value before. So when awk tries to read the current value of that, it's going to come up with an empty line. And now I'm asking it to take this empty line and increment it as an integer. And just like bash, that empty line will get treated as a 0. And so this will basically set foods bracket fruit equal to 1. If my next line has a field that says cookie, then foods bracket cookie will also get set to 1. If the third line of my file contains something which is a fruit, then foods bracket $2 will be foods bracket fruit, and I'm saying foods bracket fruit plus plus, it will read the current value, which is a 1, increment it to a 2, and now foods bracket fruit will be 2. And so at the end of all of my processing, I will have this foods array. And if I go in with some index, the value stored to that index will be the number of times I've seen that type of food show up in my input. Right? So this is like our tally program for PA5, but we're tallying types of foods here instead. And then after all input is processed, I have the end pattern, which means that this action will fire. And this is a for in type loop, right? Just like for in bash. So for food type in food. So this will iterate over the associative array called foods, and it will look for all the different indices that have been used, right? Now if I don't have a foods bracket elephant, then, you know, elephant's not going to pop up in that for loop. But if I have foods fruit and a foods cookie, then somewhere in this for loop, food type will be set equal to fruit. And some other time through the for loop, food type will be set equal to cookie. So this is a for loop that iterates over all of the indices that I've used with the foods array. And for each one, I'm going to do a print statement. And the print statement says number of %s colon %d. The %s is the food type. That's the thing I just pulled out, the index. And the %d I print next to it, that's foods bracket food type. So it's foods bracket fruit, foods bracket cookie. So this should print something like fruit colon 2, cookie colon 1. And so this will tally up all of our foods based on type, the second field, and give us a total count. And this, if you try to do it in bash, fairly complex. If you try to do this in C, extremely complex. We'll do this in 222. In awk, I mean, it's if I took out the spacing, it's 2 lines. Right? So this is a tool you want in your toolkit. And, you know, you could probably take a short course just on awk. You can buy entire books just on awk. And we're barely scraping the surface of what this can do. But even with just these few ideas, just some basic patterns, a few actions, associative arrays, you can do a lot of really powerful analysis and manipulation of text files or maybe programs. All right, here's a slight modification on this. Here I'm using as an index for my array $2 $3. What is that? It's the type of the food followed by a dash followed by the color of the food. So we're going to tally how many red fruits there are, how many yellow fruits there are, how many dark cookies there are, and so on and so forth. And to do that, all I have to do is just change what I'm using to index my associative array, in this case $2 $3. So if I have the same kind of food but a different color, this index will be different. This will be fruit-red versus fruit-yellow for an apple or a banana. And so I'll tally those separately, but then this output is the same. I just go through each of the indices in my array, print out the index itself, food type, and then print out the tallied value, which is foods bracket food type. And so if I do that, I've got 1 green vegetable, 1 clear drink, 2 dark drinks, 2 yellow fruits, and so on and so forth. Alright, so here's something a little closer to PA5. So I'm going to take an input file and I'm going to break it into fields separated by spaces. And I'm going to use a for loop on each one. I'm going to say for item equals 1, item less than or equal to number of fields, item plus plus. So if there's 5 words on a line, item will iterate from 1, 2, 3, 4, 5. And then I'm going to say count bracket $item. So if item is 1, this is going to be count bracket $1, whatever that first field is. When item is 2, this will be count bracket $2, which will be the second field. So I'm going to basically take each word of my input file and I'm going to tally it. I'm going to use it as an index to my counts array, and I'm going to increment what's stored to that index. If it's a new entry, it'll increment from blank to 1. If it's an existing entry, it will increment from its current value to its value plus 1. And I'm not declaring this array anywhere. I'm not initializing it to anything. That all gets taken care of for you. And then at the end of all of this, I'll do another for in loop. I'll go through each of my words and I'll print out the word and the number of times that it appears. So there's a tally of how many times different words appeared. So this isn't PA5, right? Because we're just doing single words. And I would rather you don't go down this path for PA5. I want you to know how to use associative arrays in Bash, because that will be on the final exam almost certainly. But this is, you know, a pre-existing tool that, you know, again, basically 2 lines if I get rid of the spaces, and we can do all of this. Alright, so with scripts, we normally begin our scripts with /bin/bash. awk is under /user/bin. So here's a different kind of script. This is a script called index. And for my shebang, I'm saying /user/bin/awk-f. And I'm putting inside this script an awk program. Now, if I tried to execute these statements from Bash, Bash is going to throw its arms up in the air and say, I don't know what you're talking about. But if I just say index, it's not going to execute these statements with Bash. It's going to execute them with user bin awk. And so now I have a script that if I just say index, it will go ahead and run this through awk. So I can say index, right, and it runs my program. So I've got the text of War and Peace here, which is, you know, 3 million characters. I can say index War and Peace, and it gives me a word index, how many times each word occurs in here. I can do a sort-n, which sorts numerically and puts the most common words at the end. So the is the most common word, 31,000 times. And if I wanted to find interesting words that occurred most often, maybe I could take this and pipe it into grep. And I'll search for a colon, and I'll search for any 7 characters. This will only give me words that have 7 or more characters in them. And so there's, you know, longer words that occurred with the most frequent being listed at the bottom. So now I can do some analysis on War and Peace and see what it's about. There's a princess and something and Russian and Nicholas and a lot of chapters and understanding everything and so on. And if I want to see the least common words, I can pipe it through more and see what's in the beginning. And there's lots of abandonment going on and some abdomen and so on and so forth. And if I wanted to see how many unique words appear in War and Peace, I can take this and pipe it into word count, right? So we don't care about War and Peace in CSE224, but if we cared about some file, we're doing all kinds of quick analysis on this, you know, for the price of typing in 1 line of Bash and, you know, a few lines for an index program. Basically a 3-line awk script. And when we do this in 222, it's probably going to be the hardest program of the entire course, because it's going to be written in C. We're going to have to build up all these data structures ourselves. Awk does that for you, right? And it bundles all of that capability inside a language that we can use to, you know, write programs like this. All right. We can also write programs that have nothing to do with input file processing. For example, here's a simple program. It has a single pattern begin, which starts at the beginning of a file, and it's a for loop, which says, hey, for x goes from 0 through 9, let's just print out x. If I just do awk-f s1, you know, there's a for loop. Here's a loop which will add the integers from 1 through 10. Right, so I have an initial sum, and I have a for loop which says sum equals sum plus x, and at the end of my for loop I'll print out my sum. And this is all, you know, an action to be taken at the beginning of file processing. And so, you know, this would normally read from standard in, but since there's no actions that match any input lines, it'll just execute this program and exit. So there's the sum of the first 10 integers. Here's our favorite program, calculating prime numbers. So I have a loop from 3 to 1001 by 2, so I'm looking at odd numbers. A composite flag, I loop through possible factors up to and including the square root of a, incrementing by 2's, and I see if a modulo b is 0, and if it is, I set my composite flag. At the end of my loop, if composite is 0, I print out my number. And I print it out with a %d and a space and no new line. And at the end of the whole program, I print out a new line. So if I run this, I've got a prime number generator. Prints all primes up through 1001. All right, so that's awk in 50 minutes. Again, that's just scraping the surface, right? There's a lot more we can do, but those are pretty useful capabilities. Possibly, you know, the main thing you'll do with it is just awk print $1, comma $3 to print some fields from an input line. But keep it in mind, right? There's definitely more you can do with it, and so that's just an example of some of that. All right, we are out of time, so I will leave it there. We'll do a similar treatment through sed tomorrow, because sed is similar, but sed is more focused on working line by line instead of field by field. So we'll play around with the stream editor tomorrow, and then that'll do us for the week. And then next week we're going to talk about processes in C, and then we'll do some review for the final exam. All right, that's all I got. Have a good one. I will see you next time.